On a Tuesday morning in June 1908, at 7:17 local time, in a Siberian forest 60 miles from the nearest village, something exploded in the sky. No crater, no body, no human casualties anyone could count. 80 million trees fell flat in a single instant, fanning outward like the spokes of a wheel. Nobody saw the rock, and nobody would visit the spot for 19 years. What if an empty forest is the reason every city is still standing? In the next 8 minutes, I want to trace something almost nobody connects. How a forest that killed no one became the founding evidence for an entire branch of modern infrastructure. The Space Telescope launching in 2027, the spacecraft that punched an asteroid in 2022, the federal law passed in 2005. They all run traceably through one Russian morning. Sit with that for a moment. Then let's go back. Begin in 1908. Russia is on the eve of revolution. The Podkamenia Tunguska River runs through a forest that, even by Russian standards, is considered remote. The nearest weather station is hundreds of miles away. The nearest scientist further, at 7:17 on the morning of June 30th. Witnesses across central Siberia report what they describe as a second sun crossing the sky from south to north. Then a flash. Then a shock wave that, according to the modern compilation by the researcher Vladimir Rubtsov, was recorded on seismographs across Europe and registered as pressure waves on barographs as far as England. In the Evenki village of Vanavara, 60 miles south of the blast, windows shatter. People are thrown to the ground. A trader named Seaman Semenov, sitting on his porch, later told the explorer Leonid Kulik that he felt the bench under him become hot enough to burn. Reindeer herds disappear. The Evenki tells stories, collected only decades later, with all the distortion that introduces, of a fire god, of a sky that split. Then nothing. The Russian Empire is collapsing into civil war. There is no expedition. There are no aerial photographs because nobody is flying yet. The world simply forgets. 19 years pass. In 1927, Leonid Kulik, a Soviet mineralogist who had read a fragment of a newspaper article about the event, finally reaches the site. What he finds is not a crater. It is an area roughly the size of metropolitan Sao Paulo, 2,150 square kilometers, where 80 million trees have been knocked flat in a near-perfect radial pattern, pointing away from a center where the trees, oddly, are still standing upright but burned to charcoal. He photographs it. He goes home. He comes back 4 times. For the next several decades, the Tunguska event is a Russian curiosity. Some say comet. Some say asteroid. Some, in the 1940s, very briefly say spacecraft. The record is incomplete and remains incomplete. As recently as 2009, an Italian team, led by Luca Gasparini, argued that nearby Lake Checo might be the impact crater of a fragment that survived the ground. Other geologists disagree. The debate, more than 100 years later, has not closed. A Soviet expedition, an Italian lake, a forest the rest of the world ignored. For most of the 20th century, that is all Tunguska is. And then, very slowly, the math catches up. Here is the mechanism, and this is the part that's traceable. In the early 2000s, a computational physicist at Sandia National Laboratories named Mark Boslow did something almost nobody had done with Tunguska before. He ran the explosion through modern fluid dynamics models. His finding, published in the Geophysical Record and presented to the American Geophysical Union, was that the energy of the blast had been overestimated for decades. Tunguska was probably not 15 megatons. It was probably 3 to 5. That sounds like good news. It is not. What Boslow showed is that an object only 50 to 80 meters wide, small enough that current sky surveys would miss it on most nights, can detonate in the upper atmosphere with a force of several hundred Hiroshimas, deliver no fragment to the ground, and still flatten a city. We don't know exactly how often this happens. Estimates put Tunguska-class events somewhere between every 200 and every 1,000 years. The point isn't the average. The point is the geometry. Tunguska happened over a forest. The same explosion, the same physics, occurring over St. Petersburg or London or Sao Paulo, would not be a curiosity. It would be a memorial, Now look at what happened next. In 2005, the United States Congress passes the George E. Brown Jr. Near-Earth Object Survey Act, instructing NASA to catalog 90% of all near-Earth objects larger than 140 meters. It is the first national law in history that treats the sky above your house as something that needs to be inventoried. In February 2013, a 20-meter rock detonates over the Russian city of Chelyabinsk. 500 kilotons, about 1/8 of Tunguska. Roughly 1,500 people injured, mostly by flying glass when their windows blew in. The event is the first major airburst captured live on dash cams by accident and seen globally within an hour. Funding accelerates. In September 2022, NASA's DART spacecraft deliberately collides with a small asteroid called Dimorphos, about 11 million kilometers from Earth. The collision changes the asteroid's orbital period by 33 minutes. It is the first time in 4.5 billion years of planetary history that a planet has reached up and moved a rock that was not moving for it. The deflection is small. The precedent is permanent. And in 2027, the Surveyor, the first space telescope dedicated to finding rocks that might be aimed at us, is scheduled to launch. The shadow of an empty Siberian forest is, by then, a budget line. If the pattern holds, planetary defense may follow the path tsunami warning systems took in the 20th century. Invisible, expensive, occasionally mocked, and then, on one specific morning, the only thing standing between a city and a number on a casualty list. We don't know what the next century looks like. The record of the future, as always, is blank. But the equipment to write it is already in orbit. So here is the shadow. An empty forest taught us that cities could be defended. The strangest thing about that lesson is that it took a place where nobody lived to convince us we could protect the places where nearly everyone does. The next century may bury this work in silent infrastructure, the kind we resent paying for, right up until the morning it works. If long shadow stories like this matter to you, subscribe. There's another one Friday.